Okay, today I will discuss about the radioisotope. This is the second lecture of that lecture series, and in that lecture series, radioisotope. So, what are the radioisotope? And there's a basic hand notes on it. So, these are the unstable nucleus molecules that you can find on that paper. So, if it is unstable, that's why the disequilibrium among the nucleus. So, in previous class, I have discussed some molecules have the nucleus part. In the nucleus part, the protons and neutrons are there, and electrons are surrounding over the nucleus. So, here the disequilibrium in the nucleus part. So, that's why such atoms to achieve the stability of the nucleus, so they are decaying. So that's why the nucleus is decaying. That is also the disintegrate, and for this disintegration that emits the radiation. So this is the radioisotope part. In the radioisotope part, some of the molecules are very unstable isotopes. So as an example, you can find that the 1H, 2H and 3H. So protium, deuterium and tritium. So in that case, the 3H3 or 3H, this is the radioisotopes. Along with that, the carbon C12, C13 and C14. So C14 is the radioisotopes of the carbon. So for the decay, so it means the nucleus is decaying. So decaying is three types. You find that the alpha decay, beta decay and gamma decay. So every type of decay, now consider the alpha decay. In that alpha decay positions, that will be like the positive charge. So it likes the 2 proton and 2 neutron. So it means the alpha decay is the positive, considering the positive charge. Now let's moving to the beta decay. So beta decay is two types. One will be the positron and another will be the negatron. So positron and the negatron. But the interesting part, there is no change in the mass. So if you are a physicist, then your interest will be the more over their positrons and their waves and all those things. But as we are the more biologist in nature, so we just consider about the application part on that. So you don't go for the too much physics part. And gamma decay, there is no charge in mass and decay. So going for the next chapter, next page for that notes part. Okay, got it. Now we'll go for the alpha decay of that nucleus portion. So it will be like yes, now the alignment is perfect. Yeah, we'll understanding now what is the alpha decay of uranium 238 nucleus. So for that section, but in all the decays we will consider the in biological system, moreover the beta decay system is found. But now consider the alpha decay of uranium in 238 nucleus. So for that, one uranium molecule, its molecular weight is 92 and the mass is 238, and if it is decaying, and this is a large atom, that's why it's an unstable one. So if it is decaying, one of the helium molecules like 2 proton and mass changes is a 4. It means 2 proton and 2 neutron. So what will be the, that will be the thorium, uranium 2, it's converted to the thorium. That's why if the 2 molecules of proton is decaying, that's why it's about the 90, and 2 molecules proton and 2 molecules neutron. That's why its molecular mass, its molecular weight would be like total mass will be 238 thorium. So it's a parental nucleus and this one will be the daughter nucleus. So this is the alpha decay of uranium 238 nucleus. Now the changes in the atomic mass equals to decrease by 4 and changes in the atomic number decrease by 2, whatever I explain it, and it is in the positive charge, and it has the max ionizing effect and the maximum penetration power. So alpha decay is more energetic and it is in the positive charge. Now we are coming to the negatron beta decay. So two type of beta decay is found. One is the negatron beta decay, another was will be the positron decay. So for that the negatron beta decay, they are negatron greater than the positron, it is found on the like that. So we will consider the carbon 14 because we previously I said that it found on the beta decay system in the biological one. So that's why we consider the C12 system. So after beta decaying, it will convert it the nitrogen 14. So it's C14, it's unstable one, but the nitrogen 14 it is a stable one, and along with that beta decay, one negatron beta minus, you can consider like a one electron type, but it's not an electron because we are taking all the system in the nucleus part. So this is the electron and the antineutrino mu. So like carbon beta decay to nitrogen stable one, and it converted to the antineutrino and one negatron beta minus. So what will be the structure and how it will change? Like let's take. So it will be like one neutron will be minus. So now let's consider for that example. This is the example on of the 3 hydrogen. So there's a tritium, and in that tritium there one proton is there and along with 2 neutron is there. So after decaying beta, so what happened? There one helium 2 3. It means two proton is coming. So one proton is coming and one negatron beta minus, it's one coming and one antineutrino. So in that case there is a no change in the atomic mass, but the atomic number is increased by 1. So if any exam purposes it is coming that you will just attach one atomic number and making the molecule to the next molecule. It's like the carbon to nitrogen and like that hydrogen to helium. So you just attach the one positive ion on that, and also you know one will be the negatron and one will be the antineutrino. Now we are coming to the positron decay. Okay, so in positron decay, okay, it's coming full, yeah. So in positron decay, yeah. Okay. In positron decay, it will be like positively charged particle and without mass. So here there one proton greater than the one neutron. So what if the proton splits? If proton splits, and that will be the one will be the neutral enter mass and one will be the no mass, but the charge is coming. So you can just split that proton. So it means proton build with some of the mass and the charge we are discussing in the first class, that will be the 1.6 into 10 to the power minus 19 coulomb. So that is the charge. So when it is splits on the decaying position, it will be like no mass charges will be there and another will be the neutral intermass. So this charge is known as a positron. So it's like exiting on the charge, but this mass is things there, mass will be converted to one neutron. So that written in the nucleus. This concept is very easy. So what happened if I take one example on that oxygen O815. This is the rare element. So when because it's an unstable one, oxygen O16 is a stable one, 8O16 is a stable one. So we take one unstable one. That's why what happened? If any one proton exit from that particular nucleus, so what happened? It converted to nitrogen. So N7. So decaying one of the proton and the mass number will be same because the positron is like only for the charge particle. So what happened to that? So one positron exit from that particular reaction. Hope that you will understand that the positron decay, negatron decay and the alpha decay. Okay. Now we are coming to the gamma decay. Okay, so in the gamma decay, so like the excess energy and it is equivalent to the one photon, so no charge or no mass, and bring the nucleus to back into the ground state to the excited state. So after emissions of the alpha and beta particles, so always the gamma decay is like the excess energy equivalent. That's why it's for getting the energetic purposes before and after of the alpha and beta decay particle. So that's why the no changes in the atomic mass number. So it like molecule will be like almost in same, but their state will be changes. So one should be in excited state and another will be like ground state. So this example of the 43 Tc 99. So it will in the excited state to the ground state, and along with that some gamma ray or gamma decay is formed. So now we go for the some of the basic things, and what are the penetration power and the ionizing power. We'll go for that. Yes, yes. So what are the penetration power? Because there is a more energetic in the gamma ray, so that's why the gamma is more penetrating power than the beta, then the alpha. So along with some the magnetic order also, and ionizing effect, because it has a low penetration power, so it can react with that molecule first. So that's why it gives some the ionizing effect of alpha along with beta, and after that beta and after gamma. So the ionizing power is more in the alpha decay. Now we go for some of the basic definitions along with the isobars, isotone. Isobar, it means some of the mass number different but the atomic number. Okay, so isobar, it means the mass number is same but the different is the atomic number, because you found that previously carbon 14 and the radioactive carbon 14 is the radioactive and the nitrogen 14 is stable one. So both has the 14 and 14 of the mass number, that means they are the isobars. Isotone, it means the neutron number is the same and but the mass number is different. So how it is possible like that? 8 O 16 in that molecule you can find the neutron number is a 8, and when is the nitrogen 7 15, it has also the 15 minus 7 equal to 8. So it has also the 8 number of the neutron, and along with the C 14, that is also the equal number of the neutron. So the atomic mass, now we go for the some of the atomic mass, because we will cover two first, otherwise it will not complete it properly. So in the atomic mass number, so its unit is the Dalton, or it is AMU, and somewhere it is written on the U also. So in the carbon is 12 AMU, or you can call the Dalton Da, and along with that oxygen is 16 AMU, nitrogen is 18 AMU. Let's say an example, and along with some water. So water is like H2O, 2H is 2 plus 16, that will be 18, and along with glucose it will be like 180. And what is the relative unit? So it's this mass number is a relative unit compared to the mass of hydrogen atom. So it's the atomic mass of the weight unit, it will be like the comparison to the hydrogen unit. Okay, now the concept is coming. So alanine is 89 AMU or Dalton, or you can say that is a gram per mole. So 1 mole, it means, so 89 gram of alanine, it's a 1 mole, and 1 mole means it has the 6.023 into 10 to the power 23 atom. So this is the number of the atom present in 89 gram of alanine. It means it's a 1 mole. So this concept is needed for the chemistry and related to the experiments. If you know and how to calculate all those things, molar number and all those things, you need that concept. So you have to define first, if any kind of molecule it has 1 mole, that means 6.023 into 10 to the power 23 atoms are present, and if these atoms are present, that means now you have to calculate the its atomic mass. How? And go for that. For if it is alanine, that's 89. If it is glucose, it will go for the 80 gram, and if it is water then it will be like 18 gram. For water it's 18 gram. If anywhere the 18 gram of water is there, you can say, oh, okay, the 6.023 into 10 to the power 23 atoms of the water is there. It's like molecule is there. So now we go for the some of the questions like that. If a protein has 100 amino acid, and what will be the mass in Dalton? So if a protein and amino acid is 100 Dalton, it's a leverage one. If you take average amino acid molecule 110 and 100 Dalton, so if they are 100 Dalton and in a protein in 100 amino acid, so how what will be the 100 into 100? So what? So it will be like 100 into 100, and the absolute mass of the proton is like 1.67 into 10 to the power 25 gram. So now you just multiply all those things. If a protein and 100 amino acid, and what will be the mass in Dalton, and one amino acid 100 Dalton, so 100 into 100 into one mass of the proton is like, because it's a relative one, relative compared to the mass of the hydrogen atom. So what will be that? Into 1.67 into 10 to the power minus 24, and it will coming 1.67 into 10 to the minus 20 gram. If the 100 amino acid in that particular protein, so it will be like 10,000 Dalton. If you convert it to the Dalton to gram, it will like there 1.67 into multiply by the 1.67 into 10 to the 24. Okay, so for that class it is sufficient, and now and after that class we will discuss with you some of the electrons arrangement along with the subcells and the cells, and the maximum number of the electrons in a cells, and they are in how the bonds form. So it is like very basic class. Thank you. Just go through all those things.